Hello everyone, welcome to Chem Past Papers. In today's video, we are solving IGCSE Chemistry, May-June 2023, Paper 4, Variant 1. And this is Part 1, covering question 1 to 4. I will explain every answer clearly, show you common mistakes students make, and share quick exam tips so you can score full marks. Let's get started. Question 1. Here, they have given us a list of equations labeled A to J, and we are supposed to match each one with the correct type of reaction. First one is a neutralization reaction. A neutralization reaction is when an acid reacts with a base to form water. So we are looking for hydrogen ion, which is from the acid, reacting with hydroxide ion, which is from the base. So from here, you can see that equation is B, as hydrogen ion from acid, hydroxide ion from base, and then we have water. So the answer for this question is B. Now, common mistake. Some students pick any equation with an acid in it. That is wrong. Neutralization reaction must involve hydrogen ion and hydroxide ion forming water. So you must see the H plus OH minus minus H2O. So whenever you see that, it's always neutralization. Next, a precipitation reaction. A precipitation reaction is when two aqueous solutions react to form an insoluble solid. From this equation, that will be equation A. It shows ion 3 hydroxide, which is insoluble. So it forms a solid precipitate. Our answer is A. Common mistakes students make is students think precipitation must be written as a full equation. No, precipitation can be written as ionic equation, just like we saw here. This is written in ionic equation. Next, the formation of an ester. An ester is formed when alcohol reacts with a carboxylic acid, producing an ester and water. So from the equations above, H is our answer. We have ethanoic acid plus ethanol to give us ethyl, ethanoate, and water, which is our ester and water. So H is our answer. Common mistake. Students confuse esterification with neutralization. Please note that esterification does not form a salt. Okay. Next is photosynthesis. Now this one should be familiar. For photosynthesis, we have carbon dioxide and water, it was glucose and oxygen, and that will be J. J, we have carbon dioxide plus water, glucose, oxygen. So J is photosynthesis. Next is fermentation. Fermentation is breakdown of glucose into ethanol and carbon dioxide. So that will be equation G. In equation G, you can see uh, glucose breaking down into ethanol and carbon dioxide. Size G. Next is cracking. Cracking is when a long chain hydrocarbon is broken into smaller alkanes and alkenes. From our equations, that would be D. Long chain broken down into smaller alkane and alkenes. Question 2. Now we move on to the period 2 element. All these elements are elements in period 2. Now let's answer the question that follows. Makes up about 78% of air, that is nitrogen. by writing the symbol. The equation asks us to use the symbols of the element. Next, has 3 electrons in this outer shell. Group number equal number of outer electrons. Boron is in group 3, which is group 1, group 2, group 3, group 4 up to the end. So boron is in group 3. So that means boron is our answer. Is B. Group number equal to number of outer electrons. Do not forget that. Next, has 9 protons. Number of protons equal atomic number. Fluorine has atomic number 9. So our answer should be fluorine F. Don't forget, use your periodic table. You can always check your periodic table. Number of protons equal atomic number. Next, exists as graphite. Graphite is an allotrope of carbon. Diamond is another example. So in this case, that will be carbon. Symbol of carbon is C. And it's an alkali metal. Alkali metals are group 1. So here, lithium, member of group 1, of lithium, and only has oxidation number 0. That describes the noble gases. So the answer is neon. All reactive elements have oxidation number 0. So noble gas, our answer is neon. Next, the definition of isotopes. Isotopes are atoms of the same element with the same number of protons or different number of neutrons. Common mistake: if you forget to mention neutrons, you will lose some marks. So please make sure mention your neutron. Next, calculating relative atomic mass. To do that, multiply relative mass of isotope 1 and the percentage abundance plus relative abundance of isotope 2 multiplied by percentage abundance of isotope 2 and divide everything by 100. So let's quickly do that so that we can get our answer. So the relative atomic mass is 10.8. Question 3, bonding. So we are asked to complete the dot and cross diagrams showing the electronic configuration of one sodium ion and one oxide ion. We are also asked to show the charges. Take note of what you are asked to do. Complete the diagram and then show the charges. Do not forget to do the box. Now to complete the diagram and get the charges, we need to write the electronic structure of sodium and oxygen. Sodium has the atomic number of 11. I check your periodic table. That means the number of electrons is also 11 because number of electrons, number of protons is the same for a neutral atom. So the structure of sodium with 11 electrons will be 281. 2 in the first shell, 8 in the second, and 1 in the third. Oxygen is having 8 electrons, atomic number 8, so number of electrons is 8 also. So the electronic structure will be 2, 6. 2 electrons in the first shell and 6 in the second. So that means sodium is giving out 1 electron, and to complete the shell to be stable, oxygen needs 2 electrons to be stable. So sodium gives out this electron, this is gone, so we'll be left with 2, 8. Oxygen gains 2 electrons, becomes 2, 8. So diagram given to us has the first shell with 2 electrons. So we are doing the second shell with 8 electrons. Same thing with oxygen, doing the second shell with 8 electrons. So let's quickly do that. Okay, so this is the complete dot and cross diagram for sodium. 2 in the first shell, 8 in the second shell. Now since sodium gives out 1 electron that was in the outer shell, the charge here will be positive. That's 1 plus. There's no need of writing the one, you just write plus sign, or you can write 1 plus. Either way is accepted. And the reason why we are adding positive is because it means that sodium has more proton than neutron. Remember, the number of proton is 11. Initially, the number of proton is 11. Number of electron is also 11 initially. After it loses 1 electron, the number of electron becomes 10. So it's having one more proton than electron, and that is why it is positive. The symbol for the charge of proton is positive plus, so it's having one more proton than electron. Then look at the dot and cross diagram for oxygen. If you observe for oxygen, we are using dot to represent the electrons from oxygen. And look at those two electrons using cross, showing us that they are the two electrons oxygen receive to complete its shell. Okay, so oxygen will receive 2 electrons, so we have our 2. What is the charge of electron? Negative. Okay, so that is it for the dot and cross diagram. Write the formula of sodium oxide. So to write formula, we need the symbol. We have our sodium. Now, remember, our oxygen receives 2 electrons. So the first electron is from sodium number 1, because sodium can only give 1 electron. The second electron is for sodium number 2, which is not shown here. But you should know that because the oxygen requires 2 electrons, and one sodium atom can only give 1 electron. That means the oxygen is going to get uh, the second electron from another sodium, so making our sodium to be 2. So for this ionic bond to take place, we will need 2 sodium, which will give 1 electron each to the oxygen to be complete. So the formula for sodium oxide will now be Na2, representing the two sodium rather, donating 1 electron each to the oxygen. And then we have our 1 oxygen, which received the 2 electrons from the sodium, 1 from each sodium. So the formula for sodium oxide is Na2O, not NaO. Please take note of that. Another way you can do that is write your sodium, the charge 1 here, oxygen 2, and you swap it. This comes here and this comes here, which will give us Na2 and O. So same thing. Next question. Carbon dioxide dot and cross. Now to do that, we write the electronic structure of each atom in carbon dioxide. So we start with oxygen. Oxygen is number 8 on the periodic table. So that means electronic structure is going to be 2 and 6. Remember, the number of electrons is equal to the number of proton for neutral atom. Carbon is number 6, so going to be 2, 4. And then oxygen, second oxygen, 2, 6. So this oxygen needs 2 electrons to complete shell. This one 2 electrons, carbon needs 4. So we start with the first oxygen. It needs 2 electrons to complete the shell. So for simple covalent compounds, the number of electrons they need to complete their shell is number of electrons they are going to share. Okay, so let's give cross to this first oxygen. So you need 2 electrons, so that means it's going to bring in share 2. Now carbon will also bring 2 because it's a simple covalent compound, so they share the same number of electrons. Now this oxygen gives us 2 electrons. Remember, we are dealing with the outer shell. So outer shell electrons only. So I'm not interested in this, and this. In the outer electron shell, this oxygen has given 2 electrons. Will be remaining 4 electrons here. So those four electrons, we are not throwing them away. We call them lone pair of electrons. So the electrons that do not take part in the bonding or lone pair. Okay, so we write them on the shell. There are four of them. We go to the oxygen. So we are dealing with the atoms around the central atom. This carbon is the central atom because in the middle. Okay, so this oxygen, the same thing with this oxygen, giving two electrons. So we are giving this oxygen cross also because the first oxygen is cross. So we give it cross also. We're giving two electrons. Then that means carbon also two. So the same thing, oxygen gives out two electrons. So this is four. These four are the lone pair of electrons. So indicate them on the shell. Remember, we are dealing with only the outer shell. So now let's check whether we have a complete shell for all of them. This is first oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So it's complete. Carbon 1, 2, 3, 4, 5, 6, 7, 8. Complete. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. So that is it. C. Why sodium oxide has high melting point? It has a positive and negative ion. There is a strong attraction between them. How do we know that it has positive and negative ion? Because sodium oxide is ionic. Okay, it's positive and negative, and there's a strong attraction between them called electrostatic attraction between the positive and negative ions, and that is why it has a high melting point. Next, why carbon dioxide has a low melting point? Weak intermolecular forces. So the forces are called weak intermolecular forces. It's responsible for the low melting point in carbon dioxide. Meaning of catalyst. If you observe this diagram, if you read the question, what is asking us first is why mass decreases. Now this is the composition of hydrogen peroxide using manganese 4 oxide as catalyst, where oxygen gas is released. So why mass decreases? Oxygen gas escapes from the flask. So as you can see, oxygen gas escapes from the flask. The cotton wool plug will not stop the oxygen from going out. Next, why rate is highest at the start? The concentration is highest at the start, so collisions happen more frequently. And the more collisions we know, the faster the rate of the reaction. And that is why the reaction is highest at the start. Next, why rate becomes zero? All the hydrogen peroxide is used up. So there is no more hydrogen peroxide to react. So reaction rate becomes or eventually becomes zero. Explain in terms of collision theory why the rate of reaction is higher at an increased temperature. When temperature increases, particles gain kinetic energy, collision happen more often, and more particles have energy equal to or greater than activation energy. Now, you look at this, I've mentioned at least 3 points in this explanation because it's a 3 mark question. Mistake student makes is most of the time students stop at the first point. When temperature increases, particles gain kinetic energy and stop there. You will not get a full mark. So we have to state 3 points. Particles gain kinetic energy. When they gain kinetic energy, what happens? Collision will happen more often. And when there is more particles, when there is more energy, more collision, the energy produced will be equal to or greater than the activation energy, which is the minimum amount of energy required for a reaction to start. So 3 points, 3 marks. Take note of that. Next, calculation. We are giving some information here. We are asked to calculate the mass of oxygen that forms using the following steps. to calculate the number of moles of hydrogen peroxide used. So first thing you check what is given to you from the question about hydrogen peroxide. You are given the volume and you are given the concentration. So now, which formula will you use to calculate the number of moles of hydrogen peroxide used? So the number of moles can be N is equals to concentration C times volume V in dm cube. Volume in dm cube. Our concentration from the question is 0.200 multiplied by our volume, which is 50 centimeter cube, but we need to convert it to dm cube. So whenever you are converting from centimeter cube to dm cube, you divide by 1000. From dm cube to centimeter cube, multiply by 1000. So that will give us 0.01 mole. Okay. Next, determine the number of moles of oxygen produced. So from the equation, there is no information given to us about oxygen except the equation of the reaction. So we cannot use any of the formula of calculating number of moles to calculate the number of moles of oxygen. Rather, we use the equation of the reaction using the mole ratio. So check the mole ratio of peroxide to oxygen. The mole ratio is the coefficient. Okay, so the mole ratio of the number of moles of hydrogen peroxide here is 2. So 2 moles of hydrogen peroxide give us 1 mole of oxygen. So that means 0.01 moles of peroxide will give us N, which is the number of moles that we're looking for. So we cross multiply, it's simple mathematics. So our number of moles, which is N, will be equal to 0.01 divided by 2, which will be equivalent to 0.005. Next, calculate the mass of oxygen produced. Now to calculate our mass, we use the formula mass equal to number of moles N times a molar mass. Our number of moles is what we have calculated here, number of moles of oxygen. Remember, we're calculating mass of oxygen, not peroxide. So this is number of moles we are using. This one. So we have 0.005 multiplied by molar mass. How do we calculate molar mass? Calculate molar mass by adding relative atomic mass of the individual atom in that compound or molecule. So in this case, oxygen O2, relative atomic mass of oxygen is 16. So we have 2 of it, so times 2. So it will be 0.005 multiplied by 32, which is equal to 0.16 gram. If we increase the mass of catalyst, so there will be no effect on the amount of product, in this case oxygen produced. Next, we have to write a symbol equation for the decomposition of mercury oxide to produce mercury and oxygen. So the question already has given us our reactant and our product. Mercury oxide HgO decompose produce mercury and oxygen. And see the oxygen is O2, meaning it is diatomic. So this is how we write diatomic molecules. They are always in 2. Another example is hydrogen. You don't write H in the equation, you write H2. They are diatomic molecules. They exist in 2. Di means 2 atoms, 2 atoms of the same element. So what we need to do here is just to balance our equation. We have two oxygen here, so we add two here to make oxygen balance. So two oxygen, but then our mercury is 1 here. We need to make this mercury 2, add 2. So making our equation balance. Don't forget, when you're balancing chemical equation, you don't add number as subscript or in between. You only add it as coefficient. Okay, so this is the equation for the decomposition of mercury oxide, produce mercury and oxygen. That ends part 1. See you in part 2.